Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. In this video lecture, myself Daljit Kaur is going to explain about some topics of the chapter alternating currents. So first of all, we are going to understand what is alternating current, what are its advantages, and what is the meaning of the root mean square value of alternating current or the mean value of the alternating current. Most of the electrical devices operate with alternating voltage. Electric supply for domestic, commercial, and industrial purposes is mainly alternating in nature. Alternating current or AC has many advantages over DC current. It is the electric current in which magnitude changes with time and polarity reverses periodically. The instantaneous value of alternating current is given by I is equal to I naught sine omega t. So it is look like a sine or a cosine wave current. Here the word I naught is a maximum value or a peak value or amplitude of the AC current, where omega is the angular velocity. We know the relation of the omega with the time period can be omega is equal to 2 pi divided by t, which is also known as a 2 pi nu, that is a frequency, and the variation of the AC is shown in the given figure. We can also calculate the instantaneous value of the voltage of an AC, which is given in the form of the sine equation, that is V is equal to V naught sine omega t. Here V naught is the maximum value of a peak current. There are the various advantages of the AC current. First of all, generation, transmission and distribution of AC is more economical. That is, it is less costly than that of the DC. The alternating voltage can be stepped down or step up easily. AC can reach distant places without much loss of electric power. Alternating voltage can be better controlled without any loss of electric power. AC is easily convertible into DC, and AC machines are small sized, having longer life and easy to use. So the mean or the average value of alternating current is that value of the steady current which sends the same amount of charge through a circuit in a certain time interval. And to now for the derivation, we are going to get the expression for the mean or average value of alternating current. So by changing the value of the omega, we have the expression in this form. Then we are going to solve the limits. So first of all, write down the terms which are constant, then apply the limits on the cos function. So this is equal to 2 pi divided by capital T. First of all is the upper limit t by 2, then cos, and when we put the lower limit 0, cos turn to the cos 0. So we have the expression minus I naught capital T divided by 2 pi, and in the bracket it comes to be 2 and 2 got cancel, T and T got cancel. So we have the cos pi minus cos 0. We know that cos pi is equal to minus 1 and the cos 0 is equal to 1. So we have the expression minus of I naught t divided by 2 pi in the bracket minus 1 minus 1. So we now are going closer to the final answer, which is equal to Q is equal to minus I naught T divided by 2 pi multiplied by minus 2. So the final answer is I naught divided by T divided by 2 pi, and it get multiplied with the 2 and 2 got cancel. So the final answer is I naught T divided by pi. So this is the final expression for the Q. So by changing the value of the omega, we have the expression in this form. Then we are going to solve the limits. So first of all, write down the terms which are constant, then apply the limits on the cos function. So this is equal to 2 pi divided by capital T. First of all is the upper limit t by 2, then cos, and when we put the lower limit 0, cos turn to the cos 0. So we have the expression minus I naught capital T divide by 2 pi, and in the bracket it comes to be 2 and 2 got cancel, t and t got cancel. So we have the cos pi minus cos 0. We know that cos pi is equal to minus 1 and the cos 0 is equal to 1. So we have the expression minus of I naught t divide by 2 pi, in the bracket minus 1 minus 1. So we now are going closer to the final answer, which is equal to q is equal to minus I naught t divide by 2 pi multiplied by minus 2. So the final answer is I naught divide by t divide by 2 pi, and it get multiplied with the 2 and 2 got cancel. So the final answer is I naught t divide by pi. So this is the final expression for the Q. Let IAV be the average value of AC over the positive half cycle. Then the current sent by it in the time t by 2 is of the formula IAV multiply the time t by 2, that is for the half cycle. So we know that we got a one equation previously, that is the Q is equal to I naught t divided by pi. So now compare both these equations. So we have I average multiplied by t by 2 is equal to the I naught t divided by pi. So from this we have the answer I average is equal to 2 times of I naught divided by pi. So this is equal to 0.637 after dividing 2 with the pi, and it get multiplied with the I naught. We can also write it in the form that is this is 63.7% of I naught. So this is the value of the average current. So the next topic is the root mean square, which is also known as a RMS value of an alternating current. So it is denoted with the symbol IRMS. This is known as a root mean square, or its another name is the effective current, which is denoted by the symbol I. So now we are going to derive this. First of all, we know about the equation of the alternating current, that is I is equal to I naught sine omega. So this current is flow through the conductor in a small time dt. When the current flow through the conductor, there is a heat production in the small time dt, and the heat is dH by using the formula of the heat, that is I square R into dt. We know the value of the I, so just put the value of the I, that is the I naught, into the sine omega t, and in this case we need a squaring, so we do the squaring, multiply with the R into dt. Then we want to calculate this for the complete time interval, that is we want to calculate the heat produced in the conductor from the time 0 to t by 2. So we take the limit from the one complete cycle from the time 0 to into the time t is equal to capital T, that is a total time period. So for the total time period we have to do the integration. So we are doing the integration by putting the limits from the 0 to the capital T, and by put the value of the heat, that is the I naught, into sine omega t square multiply with the r into dt. Then next step, take the constant terms outside of the integration. So we have this form which we have to calculate the integration. So we only need to find the answer of the integration of the sine square omega. Since we know some formulas of the mathematics, as the sine square omega t can be written as 1 minus cos 2 omega t divided by 2. So we can apply this in the place of the sine square omega t to solve the integration. So this is the expression for the h is equal to I naught square r, and as we change the value of the sine, so the value of the sine in terms of the cos divide by 2 into dt. Then we can write in this form because here 2 is the constant. So we have to do integration of this form. So now the next step, first of all write down the constant terms. After writing the constant terms, we are going to do integration of each term. So this is cos 2 omega t into dt. So now the next step, again we have to write the constant terms, and its integration is small t with the limit 0 to capital T, and integration of this part is a sine 2 omega divided by 2 omega with the limits 0 to t. Then after this we have again write on the constant terms, apply the limits for the t, minus take the 1 by 2 omega outside the bracket, and this is sine 2 omega t from the limit 0 to t. So then we do the integration by applying the limits. So the expression is written as h is equal to I naught square r divided by 2. We have now capital T because t minus 0 is left with only with a t, 1 by 2 omega. Now see here, I am doing some changes in this expression. In place of the omega, I am putting the value of the omega, that is 2 pi divided by capital T, and its integration from the limit t to lower limit, that is the 0. This one is 0. So now we have the another form of this equation. So by solving the sign, because this is only left to solve the limits for the sign. So this is equal to the sine 2 multiply by 2 pi divided by capital T, upper limit capital T, lower limit is 0. So the complete equation comes out to be 0. Then we have I naught square r divided by 2. This is the capital T minus 1 upon 2 omega into the sine. This is t and t got cancel. 4 pi minus of sine 0. The value of the sine 4 pi is equal to 0 and the value of the sine 0 is also 0. So this equation completely turns out to be 0. So we have the final answer, I naught square r divided by 2 multiplied by t. This is the value of the heat produced in a given conductor. Here we are using the symbol IRMS for the RMS value of the AC current which would flow through the conductor for the complete time capital T. We know the formula of the heat produced in the conductor is equal to I square R. But in this case we are taking the current as a IRMS current. So the formula turns to be I square RMS into RT. So I mark this as the equation number 1. Earlier we calculate the value of the heat for the complete cycle, that is equal to the I naught square RT divided by the 2. So compare both these equations. I mark this as the equation number 2. So after comparing both the equation, we have the I square RMS RT is equal to the I naught square RT divided by 2. So by solving it, we have the answer, that is the I square RMS is equal to the I naught square divided by 2 and IRMS, and by avoiding the squaring we have I naught divided by under root 2, and by solving 1 upon under root 2 we have the value, that is a 0.707 I naught. So this is the value of the root mean square in terms of the maximum current.